towards the end of the lecture. For now, let's get started. Great. So can you guys just a second? Can you guys see my screen?
Yep.
Great. So I will start presenting this and right. So today's class is more wrapping things up, and we'll basically just be looking at we'll look at some very little new things, but mostly it's going to be a recap of all the things that we've done over the past 5 lectures. And I'll talk about some final logistics for the project and how we'll end everything. So yeah, let's get started. So as a quick recap, the one thing that we've been working on for a very long time, we've talked about this multiple times, is thinking computationally. And we talked about how we first need to come up with an algorithm. We first need to think about the steps that would be needed before we go into the details. So if you remember the plotting of COVID numbers in India and Canada problem that we looked at in the first class, in the first assignment, we didn't make a diagram like this, but I think that, now it'll be clear to you what we were doing. Was that we first, so if I was to do something like that, I would actually think in my head in terms of this flowchart. I would think about, all right, let me read the file, and I'll loop over the lines. I'll get the relevant information in each line, and I'll keep appending it to a list, and then I will plot it. Once I have this in my head, this is the algorithm to solve the problem. In computer science, typically when they use the term algorithm, they use it in a more concrete setting. But essentially the underlying meaning is always the same, that you're trying to come up with the steps necessary to do something that you want to do. And once you have this in your mind, then you can start working on the details for each of them. So if one of the pieces is unclear how to do, then you can just Google it, because you can go to Google and say read file in Python, and that would take you to the block on the right, which is with open as if you can do something. Same goes for looping, for getting information out of strings from a line, appending into a list, and plotting. The reason why we do this basically is because the way computer science develops is that people make these blocks that are available to use, and you need to break down your problem into the right sized chunks, into the right sized piece, so that you can Google and you can start building off of that. So first solve the problem and then write the code. That's something I cannot stress enough. And in, I guess, all of your projects that I've discussed as well, I have stressed on this, that you should first come up with a simple setup which you can work by hand, and then we will look at which piece can be solved with computer science, which piece can be avoided. So for example, just to give everybody in like more concrete example, in Rajshree's suggested project, she wanted to go and get some relevant details of court cases from the Delhi High Court website. And so we followed a bunch of steps, and a program would have had to do all of them. And by looking at certain things, we realized that one of them is not something which is done many times, and it's like it needs to be done just once, and it can be used for a bunch of months after that. So it's easier if you let the human do that and avoid some computational work and some programming work and make it slightly simpler. So think about the different pieces and attack each of them separately. That's something that's very, very important. So what blocks do I need, and how do I put them together? We've talked about this multiple times. And think this before you get into the details of the blocks. That's extremely important for your project as well. Great. We talked about the important elements in Python programming. We looked at variables. When we say we initialize or declare a variable, when we say a equals 1 or b equals 2. These are mostly objects, lists, dictionaries, things like that. We looked at operators, which were a plus b, a minus b, things like that. We saw some inbuilt functions. We saw modules. If you can't get enough stuff done with with inbuilt functions. So if you see, what I have here is the different kinds of elements you see in Python programs, but also there's a certain order here, is that most of the stuff that you're doing is done with variables. Variables sort of lie at the heart of whatever you want to do, because you typically want to start with some piece of information and do something to it. And that piece of information is usually stored in a variable, in a dictionary or a list or something of that sort. Once you have it stored there, then you can start operating on it. And if you operate on it, you can add them, subtract, so do something more complicated. For some very commonplace complicated things like sorting a list, Python already comes with them inbuilt because they're so often used. So those are inbuilt functions. Sometimes you may need to use something which is not that commonplace that it comes inbuilt, but it's used very often in a particular context. So for example, plotting of images or figures is used very often, but it's not that important that it comes inbuilt with Python. So for that, you have modules that enables you to use other people's code, and then you can build off of other people's code. And if you go one step beyond, you may want to do something that's very custom and that's just useful for your use case. So you just write a custom function for that. But the flow here is that information is stored and it is operated upon. And depending upon how commonplace that thing is, you may find it available or you may need to create it yourself. We talked about functions being the building block of most of Python programming, and that is something I would strongly encourage you even going forward. Even if you have to use it only once or twice, still put it in a function just for better practice. When you're doing all of these things, there's a bunch of decisions to be made. For example, you may need to, so this is what we call controlling the flow of code. And this sort of goes back to the visualization we talked about in maybe class 2 or 3, where we looked at how Python code is executed line by line, where we were, there was a red arrow or a green arrow, and we were pressing and passing through a loop multiple times. So ideally in a Python program, things are executed from top to bottom, line by line. But sometimes you may want to do something only conditionally. That is, if a certain value is something, do this, otherwise do that. So in that case, the way it works is that you're actually not executing all lines. You're deciding which lines get executed. For example, when you have an if else, depending upon a certain condition, the lines inside the if may or may not be executed. So you're controlling the flow of how code works. That is, an example of if else. Another example of controlling the flow is loops, where you may want to do something over and over again while some value is changing. So this is I would say, the basic anatomy of all Python programs. And I think after all the lectures, I think this should probably make sense now. And if you see a typical Python program, you should try to break it up into these aspects to understand what's going on, someone else's program. We looked at variable data types. We talked about, numbers that come with operators like plus, minus, multiply, divide. We talked about strings that come with functions like split and replace. Booleans is something we didn't touch upon, but we used it. So if else conditions, when we say if a is greater than 0 or something of that sort, a greater than 0 is a condition, and it is either true or false. And you could ideally set that equal to a variable. You can say, something like, a equals b greater than 10, where, b may be a value that's already stored above. And if the statement b greater than 10 is true, then a will be set equals true. Otherwise, a will be set equals false. And Booleans are specifically made for true false kind of settings. It seems very, very futile if I present it like this, but a surprisingly large chunk of computer science relies on Booleans. In fact, transistors are always Boolean, so everything gets broken down into Boolean operations at the base of it. So it's something that's good to know. We talked about typecasting, which is, converting between these different data types, like converting between, if you have a string like 1, in this case, you could convert that to a float type by putting a float and then bracket 1, which will give you 1.0, which is a float data type. We touched upon float a little bit, but basically floats are just numbers with decimals. And there's different kinds of numbers with decimals depending upon how precise calculations you want to run. For example, in my research, one problem we ran into last night actually is that the variable type that we were working with was not precise enough. So when you run very, very fast, very small calculations, it can lead to errors which you didn't expect. So you may need something like 10 decimal places, because 5 decimal places is just not enough accuracy. So there's a lot of different details there, but I think now if you see a new data type, you would know what a data type is. We saw a lot of different objects for storing these information. We saw lists, tuples. Tuples is basically a list. It's immutable in the sense that if you create it once, you can't change it. Why would that be important is something, it's not that important. It's honestly, you probably will never use it. I don't remember using a tuple ever in my life. The only thing is that it's like a list. If you see someone else use it, you should think of it as a list. The only difference is that in a list, you can keep changing information inside it. You can append to it, you can change it. Tuples can't really be modified once they're created. And in other languages, or people who program in other languages might refer to lists as arrays. and that's a very commonplace lingo, so I thought you guys should know it. And there's dictionaries. We talked about file handler objects. We talked about sets in the previous class, things that are good for intersecting objects and finding common objects between them. That's again a different kinds of object. There's a bunch more. If you see a new one, just look it up online and understand what's going on. We talked about making decisions based on some condition like if else. So here's an example, and we just saw the same example. These conditions, a less than 2000, is actually evaluated as a Boolean. So the way Python will run this program is that it will go to this if else loop. It will see if, and then it will see a condition. So it will first evaluate the condition. It will evaluate if a less than 2000 is true or false. If the answer is true, then it will see this as if true, print something, and whatever is true is executed. That's the way it works. If that turned out to be false, it would not have executed this piece of code. So that's the anatomy of how an if-else code block works in some sense. We saw that we can combine these together. We saw an example of lists plus for loop plus if-else plus dictionary all in one. We saw this that we have these two empty lists. We loop over it. We check if the salary is greater than, then we store something, otherwise we store something else. And I think now this would be less scary than it was when we first saw it in lecture 2 or 3. Right. Are there any questions up till here?
No.
Great. So we talked about custom functions. That is, we use the keyword def, and then we write a function of our own. And the function is always thought of as an input output and a box in between just doing something. So we can create this function called def Pythagoras, which takes in side 1 and side 2 and returns the hypotenuse of a triangle. It's possible that the function doesn't return anything at all. There's no outputs. It's possible that the function takes no inputs. There's no inputs. Both are allowed. Both are fine. But usually you would be using it in the setting where you have an input and an output. Another thing we talked about in the functions case was that whatever is created inside the function is not accessible outside because of scoping. If you guys might remember that class. We talked about nested functions. I didn't use the term nested functions, but we just talked about print squared 64. So here 8 goes as input into squared. That returns an output, which is 64. I'm sorry for the typo. That should be print squared 8. And when the 64 goes as input into a print function, it basically just displays it on a computer as the number. And that's called nesting functions because you're nesting one inside another. And this is also called a function called stack. And it's called a stack because it's executed just like if you had a stack of pages, you would first execute one, then the other, and things like that. So there's in more computer science classes, you would look into things like stacks and heaps and a bunch of different ways how these functions can be executed. But honestly, that's a little too much detail that you don't need to worry about. It's just that if someone says online or somewhere error called stack or function called stack, you would know that this is what they're talking about. That's used very often in online conversations on GitHub or on people discussing code errors very often. We didn't talk about this, but you can also loop for loops, and there's two things here that this is also like a reminder of things that I wanted to talk about. One is that we tend to often use for loops in the use case of for I in range 10. Now, but I've also used it once or twice in this setting where I have a list and I use a for loop over it. Was this ever a confusion or was it clear? If there's just a quick question, was this confusing when I talked about this in two different settings? Great. So I thought that it might be confusing, so I'll just repeat it once again. When you say for I in prefixes, and if I just say print I, it will go through prefixes, the list one by one, and it would have printed multi and then uni, and then it would have been done with the loop. When I say for I in range 10 is basically an inbuilt list that Python gives you. So if you do range 10, it gives you a list from 0 to 9. That's just an inbuilt function that Python gives you for ease of looping over things. I could also have created my own list and said list 1 equals 0 to 9 and then looped over that. But range just comes inbuilt in Python and just used very often and makes it very easy for you to loop over things. So here what I'm doing is I'm actually looping over two things. The way this works is that it first goes inside the first loop. So for I in prefixes, it will go and it will read I, it will set I equals multi. Then it says for J in words, and now it executes that. So the way it works is that it executes the inner loop completely before it increments I. So what this means is that it will go through, when I go over this, it's going to go multi-form, multi-dimensional, multilingual, multilateral, and then it will update the loop outside and set I equals uni, and then it will do uniform, unidimensional, unilingual, unilateral. Is this clear?
Yes.
Okay. So also another thing I've done here is that I've given a quick recap of string formatting, which we touched on in the last class, where we use this percentage %s kind of symbols, where it is just a way to format. So, I could have said print I and then print J, and then multi-form, multi-dimensional would be on two different lines, like multi and form would be on two different lines. If I want to print the values stored in variables in a certain format, it's called string formatting, because you're formatting strings. And percentage %s fills in the value that is after the percentage outside the quotes. Now, this was touched on a little bit in the last class. It's actually quite useful for when you want to output your program outputs. So it's something that's good to know. Great. We talked about the for loop. We've never talked about the while loop. It functions very similarly. In for loop, you have for A in range 10, print A, it's going to print 0 to 9. A automatically gets incremented, automatically moves on to the next element of the list. That's the natural setting for the for loop. It's not that the value of A is increasing, it's just iterating. That it's called iterating. It's just moving over different elements of this list, range 10. So range 10 is a list, and as it moves, it keeps setting A equal to different elements of that list. The while loop is typically used for more numeric looping. So you may want to, do something. So for example, imagine that I want to get the top 10, I want to get, maybe I'm looping over a really long list of employee names, and I want to stop once I've seen 10 people who have the first name equals, I don't know, could be something like say Sam or something. So there's a lot of Johns in data sets, and you want to stop after you've seen 10 Johns. You don't want to see any more Johns after that. So you could start and you can say John count equals 0, and while John count is less than 10, and I could keep searching. But once I've seen 10 of those, I can stop. This is used very often in a lot of settings where you may be working through a very large like data structure, like a list or a dictionary, and you don't know when you will encounter what. And there is a hard condition after which you want to stop processing. So it's very much like the for loop, but in this case, the important thing is that you have to set the increment yourself. So here, what I'm saying is, while A is less than 10, print A. If I just run that, it'll set A equals 0, and it'll keep printing 0 infinitely. In fact, your program is going to crash because it'll never stop. The way it'll work is that it'll check this condition, and as long as it is true, while that condition is true, it will keep running the code block below it. So since A was 0, it's going to print A equals 0, and then it'll go up and it'll see, is A still less than 10? And the answer is yes, it is less than 10. So it will keep printing it, and it'll get stuck because it will keep trying to do the same thing. So you have to manually add increment where you say A plus 1 equals 0. This is a fancy way to say A equals A plus 1, which is that when I say A equals A plus 1, it's basically increasing the value of A by 1. So what it means is that set the variable A equal to the old value of A plus 1. And shorthand for that in Python is A plus equals 1. That's just to make coding faster. Python just provides a lot of shorthand so that coding can be more. We talked about list comprehensions a little while back. If that rings a bell, that's another way to make coding shorter or faster in Python. So yeah, that's the while loop. It's very much like the for loop. It's slightly different and it's used in different settings. This is this is just a quick recap of this example that I talked about, where we were looking at different ways how this gets run. So you could actually go and run the example of the nested for loop that I showed through this visualizer to understand what's going on, if you want to understand how nested for loops work. But yeah, in general, I would suggest playing with blocks of code using this visualization tool to just better understand what's going on there. We talked a lot about, how to debug this code. We talked about, you have a code which runs, but you don't know what's going on. Or sometimes you copy paste a bunch of code from Google and it doesn't make sense and you want to adapt it, so you're stuck. Or it may not run in your case. You may have a bug. So how do you go about these things? We talked about errors and, debugging them. We talked about how you should first try to find the line number where things are going wrong. So the error call stack would typically give you, oops, sorry. This is, I don't know why it's happening, but basically it would return you a line number and the kind of error. So we saw in class 3 or 4, a bunch of different types of errors that you can run into. We saw syntax error if there's an error in the syntax, an index error if you're trying to index a list at a position which doesn't exist. For example, if your list has 10 elements and you're trying to index it at the 12th position, it's going to give an index error. Excuse me. We talked about the key error, which is where you're trying to index, you're trying to find a key in a dictionary which doesn't exist. There's name errors, which is if you're trying to use a variable which does not exist. There's type error, for example, you're trying to multiply two strings together. That's an operation that's not meant for strings. It's going to give you an error. There's indentation error, which is if you're spacing in Python, the way you're inside an if block versus if you're outside an if else block is based on the space, the indentation into the right that you make for the text. If there's an error in that, you may have a problem. Just to speak a little bit more about indentation error, this would happen a lot if you start mixing your code with other people's code. That's because there's no standard for how much should you indent. When you press a tab or when you make a space bar to indent in Python code, it's unclear to the program that the Python how much indentation should be made. Should it be 4 space bars? Should it be 2 space bars? Things like that. So there is in computer science circles, there is this whole tabs versus spaces debate where people fight over, where some people like to use the tab, some people like to use the space bar, because tab is usually set as 4 space bars, and if you press tab, it jumps 4 space bars. Now this may seem like a very super detail that's never going to be important, but trust me, once you start mixing your code with Stack Overflow, this is going to happen, because someone may be using 2 space bars, you may be using 4 space bars, and this just compounds very quickly. So it's something to look into. If you have this error, see if you've mixed some code and that's the problem. We talked about the module not found error, which is if you're trying to load a module which doesn't exist, or if you're trying to import a module which you haven't installed yet. So you may need to use pip install something to install that module before you can start using it. And we also talked about the way pip works is it basically has a directory where it stores all of these modules as Python files. Python modules are Python files. You can technically go and read them to understand. As you get more advanced, you will have to read them and understand what's going on. And it becomes less scary as you sort of do it more and more. The golden thumb rule is print everything. See which line number breaks. Add print statements above it for everything. Add print statements below it for everything that seems reasonable. Maybe 2 or 3 lines above, 2 or 3 lines below. And scrutinize to see if any line is doing something which is unexpected. Sometimes this reveals, why there is a certain error. For example, if it gives you an index error, then a good thing would be to actually print out the index that you're trying to see, or to print out the list and see if you're trying to index the wrong list maybe. So things like that. We talked about scope and how that also leads to some errors. We talked about how there's 4 kinds of different scopes. There's the built-in, which is always available. There's global scope, which is set by you. There is enclosing scope, which is inside functions. And there is local scope, which goes one step deeper. So yeah, if you want to set a variable inside a function and use it outside, you will have to start with the phrase global. So instead of saying x equals 1, if I say global x equals 1, then that is set as a global variable and it is accessible from everywhere, even outside the scope of the function. And yeah, this is something that's important to know and remember when you're debugging code. I also quickly want to go over some, excuse me, quickly want to go over some quick concepts that were left out. So first of all, what do I mean when I mean left out? Well, this is what I did. So I opened Safari and I just went and searched for Python introduction tutorial, right? And I'm here. And this is not a tutorial, but oops, sorry. So let's search introduction to Python or something like that. Yeah, so I came to this link, which is probably one of the biggest introduction to coding kind of websites. W3 Schools is something that it's big for HTML, CSS. I've used it a lot myself for JavaScript when I was trying to make some websites and things like that. It's in general a pretty good resource for a lot of learning. You know, it's detailed, and if you come to these places, you can see there's a lot of tutorials here. And I actually went over this list on the left, and I made sure that I have covered everything. So I don't do it in the way they do it, which is, you know, just like a list of things. I try to mesh all these together so that it wasn't just a list of concepts, but more like examples. But I can give you reassurance that we've covered all of this, apart from a very short list of things, which I've listed on this slide here. And the things that we haven't done is we haven't made custom classes and objects, which is something I intentionally left out because I want you to do that during your project. That will give you the confidence that, you know, you can actually read other people's more complicated production level code and you can understand it. It's going to be a big boost in your confidence, trust me. And this custom classes goes hand in hand with a concept called inheritance. So first of all, what is a custom class? Is that a file handler object or a list object or a dictionary object comes inbuilt with Python. But sometimes you may want to make your own object. And when I say object, it's like I create an object which comes with its own sort of properties or its own functions. For example, if I'm maintaining information about employees, I may create an employee object. And an employee object will probably come with inbuilt functions, which you have created, like get salary, get address, get team name, get role. These could be information. So the way this works is that if there is an employee and you want to store some relevant information about them, it is just a very structured way that every employee gets created as an employee object, and they have their own salary, address, team name, boss name, role in the company, things like that. Now, you may also have different objects for different kinds of employees. For example, you may have a different, the things that you store for an accountant would probably be different for the kinds of things you store for a coder, for example. But they all will have a salary, address, team name, and a role. They may have something extra. So you could create an employee object and you can create an accountant or a coder object. And the coder object would inherit all of the functions that are in the employee object, because they're all still relevant, but they may have some extra along with it. For example, for a coder object, you may actually have something like, you know, comfortable languages, which would make no sense for an accountant. For accountant, you may have some other kind of stuff like, you know, certifications or another kind of thing like expertise or things like that. So this concept is called inheritance, which is that if you create a new class, you can pull all the details that are relevant from a pre-existing class. And the way to say it is that this child class inherits from a parent class. So accountant class would be a child of a employee class. And the relationship between classes and objects is something I talked about in the first class, but we didn't use it. Is a class is just a definition of things for an object. So when I create a new object, it would be of a particular type. It will be a particular class type. So for example, I could be an employee and I would be, you know, Spandan employee object and say Someone else can be another employee. So they will have their name, employee object, but will both be instances of the employee class. Is this concept clear? Or I can go over this once again if anybody has any doubts.
Seems clear so far.
Great. Does anybody else have any questions about this? Perfect. So then in your projects, I would encourage you to create objects and maybe write a class or two, because it's going to help a lot later on. Apart from this, on the list, I saw some other things which are honestly easy to learn when you need them, so you don't need to worry about them right now. Lambda functions is just a fancy shorthand Python way of writing functions. Instead of def something, you can make it shorter. It's just confusing and I never use it. I'm being very honest. People like to use it, so you need to know it to understand other people's code sometimes. JSON is a format for reading and writing files that's used across the world a lot. So you may see it, you may need to read some files. Instead of storing them as TXT files, you may end up storing them as JSON if they're more complicated. Say if you're downloading a data set or things like that. Excuse me. Regx stands for regular expressions. That's basically, it's just ninja level string matching. String matching is somehow extremely important in a lot of programming. I haven't used too much of it, but a lot of people use it. So regex is again something that you can learn very easily if you need. Another thing in the list that I saw was iterators. Honestly, it's probably one of the most useless things that I've seen in Python. I studied it in a class that I was seeing, and my professor suggested it as important. I never understood why, and I would strongly suggest against using them. For loops, while loops, and some basic iterators are enough. Don't worry about the stuff if you see it. But yeah, so I think I'm pretty happy that I've covered a bunch of these things that are taught in introductory Python tutorials, and I think that you should have the confidence, you should feel confident that you actually have covered enough ground that you can get stuff done now. And the purpose of the project is indeed to give you that confidence to actually go ahead and build stuff. So yeah, what I'm going to do quickly is, we talked a lot about learning to learn, Googling stuff and getting things going and getting it done. It's not about what you know, it's about what you can figure out and how you can get it done. We saw an example of using matplotlib to change titles. That was an exercise. You guys did it. It was great. I searched for beautiful soup and scraped the internet live in front of you in a class, and then you guys did it again. And so it's not very hard to learn something new in Python and to use it. We can do some more today, and hopefully you'll do a lot more of it in your project. So for example, I know that in Rachi's project, she needs to maybe send out an email using Python. And that's something that she can, just search online, send email using Python, and then do that. I know in Malvika's project, she may need to work with some images, and we haven't talked much about images. So she can probably look up, image crop or image rotate or get intensity and things like that. And she can Google that, and that will help out. So what I'm going to do now quickly is do 3 or 4 more quick case studies, so to say, of exactly the same concept, because I want to end on the note to give you a reminder that the things that you've done so far are actually enough to start doing impactful, useful Python programming, which was all the while the important, I guess, the guiding principle in my head. So case study, let's just quickly go over these case studies, one by one. Let's see what we can get done with just searching on the internet and seeing what we get out of it. Great. So we will search for this one. First of all, let's say this one says making a user clickable button with Python. Let's copy this, search this, and see what we get. So this is the first link that we see here. I open this. It talks about something called Tkinter, which is actually a library, which we can say it's actually a module, as we call it in Python. We know that because we see this code and we see import Tkinter as TK. But this means that it's loading this module by the name TK. So everywhere we say TK, it's basically referring to this module. Okay, so let's just get this code, and I'm going to open Atom. And I have it stored in this function here. I just copy pasted it here basically. So what I'm going to do is I'm also going to open a new terminal window. And you can do this in Google Colab. It's perfectly fine. Don't worry about that. I just have this set up in my system because I use it more often. So I'm going to do this. So if I do this, I copy pasted this code, and here is a full-fledged button application. I could press hello. It is going to do something, and if I press quit, it's going to quit. So this shows me that if I want to make a user interface where I can show something to a user, make a real desktop application. You can do that with Python. It's not that difficult. You can actually make a Python application and send it to someone that people can use on their own system. Maybe make a tool for the people in your office or something of that sort. And now you can do it. Another application is, if you want to get user input, instead of making a clickable button, you can just say get user input and search that, and that will be the answer as well. It's pretty easy as well. If you Google it, you will find out. So let's see. Sometimes you want to get the time, because you may want to see, for example, you make a user study where you're measuring how much time does someone take to perform a job. So you may want to get the time in Python, and then you may want to subtract it or something. So let's just do this. Okay, so see the first one here. And honestly, you can see that some of them are purple because I've probably searched them in the past few days. So just a second. Can you guys see my screen again? Hello, can you see my screen?
Yes.
Okay, great. So what I can do is I can quickly go and search for this. Let's copy paste this now and see what this gives us. Oops. I'm just going to rewrite the same file so that we can keep using it quickly. And let's run this. Okay, it gives me the current time. Maybe we can just search for subtract time, Python. So I just copy paste this. And I could have something here in between. So one common use case is that if you want to measure how long a particular piece of code is running, you may have something like time 1 set here. You have a bunch of code in between. Then you have time 2 here. And then at the end, you say print time taken, %s, time 1 minus time 2. And if I run this, I'm going to have to add something in between. Otherwise, it's just going to be, just won't take any time. So I'm just going to add this print statement a lot of times and let's see how this does. It's probably going to be some very small number. Okay, there's an error. So this is something which is unexpected, and I will just go and Google this. Maybe it's this thing. Okay, interesting. So we'll have to turn back to what we had before. Let's just quickly see if that works out. We had this, and we would have something like start, and we have print 1. We'll do this a bunch of times. We have end, and we can just say print start minus end. Let's see if this gives us an error. Oh, this works out. All right, worked out. So this is the time that it took to run. This is actually a very interesting number. It says it took it -1 day and these many hours to run. The reason why this is happening is because in computers, if you run calculations at very, very small time frames, it sometimes gives you something completely nonsensical. So this is almost cheating, I would say, but I'm going to do this here, and I'm going to add a sleep in between. I think this should give us a larger number now. Oh, okay. Unclear why this is happening. So you add, okay, so you add this to this, and then you get 4 seconds. That's why. Another reason why in Python time is a little complicated. So you'll probably need to, you know, format it the right way to print and get the right answer. But basically, that's next step. You just Google it and see how do you do it. How do you say, so Python print time seconds. I'm just going to give you seconds. But yeah, so here's an example for how you could be, you know, building on top of things that you have in Python. Another example is reading and displaying an image in Python. Let's quickly do this as well. This. Let's see. Python display image. Okay. Let's see this. Okay. So we're going to need a picture for this, and I'm not sure, you know, which how to proceed. But basically, if you copy paste this code, this should work out. I don't think I have PI library installed in my computer right now, and it'll take time to install it. But basically, if it's not installed, you install it using pip. I could just say, actually here, this is an interesting question. Let's see if I can pip install PIL. This gives me an error. It says could not find a version that satisfies the requirement PIL. No matching distributions found for PIL. Now that's confusing because I'm clearly importing something from PIL, but it gives me an error. So it's unclear what's happening. So maybe I should search. And what I see is that this is sometimes something that happens in Python is that the library name, which is installed, is not exactly what you import. PIL is actually an example of that. It's the library name is Pillow, and it's an interesting story why it's called that, but maybe that's something that you can Google. But it's called Pillow, and it's not imported as Pillow, it's imported as PIL. Now, that happens sometimes. I personally hate it a lot if that happens, because I really like the neatness of using the same library name which is installed, and which is, because, you know, if you want to install NumPy, you would just say pip install NumPy, and that should work out. So if I do pip install NumPy, this should work. It says requirement already satisfied because I already have this installed. And if I want to import this, I would just say import NumPy and it will work. But this is not the case with always all the libraries. So if you face this sometime, you now know why it happens. Great. This is something that's, I would say, you know, it would seem like not very useful right now, but it's actually quite useful. Is that sometimes when you want to run a script or a Python program to which you pass some information. So it's called passing an argument, but that basically means you're passing some information to the Python code. So, you know, you may want to do something like print this function just prints the string that is given to it here. So the reason it may happen is because you may have a bunch of files and you may want to run this script on only one of those files. So you could take the input from the user here, and the way to do it is actually, well, why not, let's just Google it. Pass argument to Python script. You'll see that it's not very hard to do. Okay, let's see the first one. Okay, let's see how this works. It's asking me to keep this code here, and it's asking me to pass this in. And let's see if I run this, what do I get? Interesting. This error, if you ever see it, is probably because there's two Python versions, Python 2 and Python 3, and we're using Python 3.7. In Python 3.7, you don't have spaces here, and As you can see, there's a lot of, errors that you keep running into when you start Googling and understanding what's going on. But this is honestly the best way to learn. And I would suggest you to keep playing with such code from the internet. And as you can see, what's happened is that I passed in 3 arguments here. It says passed in 4 arguments. The first one is the name of the script, and the next 3 are the ones I passed here. So if I do something like, SAKL, it returns each of these. So in principle, what could be happening is that I could, I could be performing any kind of code below here, code here, and that uses a file name. So I could just say file name equals sys.argv1. So as you can see, sys.argv is a list because you are determining the length here. You can do print sys.argv. And if I run this piece of code, it's a list. It's a list with the first one always being the name of the script that I'm running. So if I change the name of the script, this would change from button.py to something else. The second one, so sys.argv1 onwards, is what you pass to the script after the Python script name. So if I do print on this, and if I pass here, say this, it's going to print that. If I pass here something like, the path of a file on desktop, something like, abc.py, it's going to print that. And in principle, this could be something that's passed into this script and is used here in the code below. So, these are just really quick, short examples that I wanted to show of things that we haven't really talked about in class, but are actually very important things that you use. But it really doesn't matter because you can Google them and you can get them done in, maybe if we do it the first time, it'll take you 10, 15, 20 minutes to understand what's going on. But the important thing is, in my opinion, think computationally how to break up your big task into smaller things. For each of these, you can Google, you can understand what's going on. You can try to break down whatever code you see in terms of all the components, the while loops, the if loops that you're seeing. You can try to adapt it to your use case, and debugging will help you do that. And the concepts that have been left out, these kinds of little things can just be Googled and you can get over. There would never be a time, honestly, where you're done with all of them. I keep Googling these things all the time, and I've been coding for about 4 to 5 years now. So I would say that there's always, tiny little new things to be learned in coding, and it's perfectly fine. That's the way it proceeds. You always write up something, Google something, incorporate that into your code, move on. And yeah, that I think that is sort of exactly how programming should proceed. And it's perfectly fine if you have to Google and look up stuff on Stack Overflow or on some kind of tutorial. So that brings us to the final logistics. And I think that the projects that you guys have mentioned are actually very fascinating, and I'm really looking forward to some interesting projects here. And once you all have, you're all working at your own pace, and that's perfectly fine. I'm more than happy to guide you and suggest you, because you're all working in projects that are related to your work. So I'm doubly excited about seeing the results. And we'll have one-on-one meetings. I would still very strongly encourage you to post things on GitHub issues, because you're going to run into the same issues. It doesn't seem to be the case given how different your projects are, but I can bet you'll run into the same issues. Lists, dictionaries, functions, syntax, indentation, all those kinds of stuff. And learning from each other's code will definitely help you. I'm going to make a final exam, which sort of is going to be mostly objective questions, followed by, I would say I would just ask you to think computationally about a few problems. And apart from that, I think that's all that I wanted to say. I hope that at the end of all of this, you have this repository of computational tools that I give you, and hopefully we can, once you're done with the project, you can add to it. Maybe I'll add your projects, and you can add to it even any other ideas that you're not working on. just to have a list of cool computational problems that people could be working on. And if you want to discuss them or ideate on them, we could always do that. But yeah, putting it all together, I think you have all the pieces now that you need to use computer science or Python programming. And I'm very excited to see what you build with them. So that's basically all that I have for this class. Yeah, that's what I wanted to end with.